different kind. Whenever we're talking about an object moving a certain amount of distance, what's the formula, remember, from before? Distance is equal to what? Okay. That's the formula we're going to use whenever we're discussing the movement of things, and it's actually uniform motion if you want to be official. But whenever you're discussing the movement of objects. So in your table, usually what you do, because to be consistent with the other, we'll put the equals on the right. Whatever you're talking about, you usually put the rate, the time, and the distance. Because it's rate times time equals distance, right? And that's the way you fill it out. And then once again, it's always the typer name over here. To help keep your stuff organized. But functionally speaking, it's still the same exact thing. You fill in each of these columns, multiply across, and you're adding on the way down. So it's really not anything too different. Let's look at two examples of it, though. I'm going to do two because I think that'll make it easier if you see more than one example. So the first example I'm going to do straight from the book. It says, a car leaves town traveling 40 miles per hour. So in this example, we have, let me select this and copy it actually first, because I'm going to use it more than once. So we have a car going 40 miles per hour. Two hours later, a second car, so there's the first car. Then we have a second car. Leaves on the same town, on the same road, going 60 miles per hour. In how many hours will the second car pass the first? How many hours till the second passes the first? And notice something else. As far as time, we're going to put time in the table. What do we know about the cars? Which car has been driving longer? It's a 2-hour head start. And of course, you can think about the way you categorize your data a little bit differently. I'm just going to say head start because I like to think about plus, not minus, with my stuff. Okay. So when you fill in the table, you do it very similarly. You're going to start off by saying, okay, first car. Then we have second car. What's the rate of the first car? Okay, 40 miles per hour. The time? We don't know the time. So we know whatever the time is of the second car. The time of the first car is that time plus what? Okay, plus 2 hours. So we don't know the time that the cars have been traveling. But if we talk about the time of the second car, we know that this one's been going plus 2 hours. Now, another option for you, if your brain prefers it, is you could have said time here and t minus 2 here. You know what I'm saying? As long as you have a relationship between the times where it shows that one car was on the road 2 hours longer. You guys see what I'm saying? I just did plus 2 because the author did it, so I'm trying to be consistent with the process shown in the text. My brain may have done the minus 2. I don't know. The idea, though, is that 2-hour head start's being shown on the first car with the plus 2. What's the distance of the first car? This is just in the book with the stuff I wrote in black at the top. It's actually like Objective C on page 117. It's the word problem. But the distance of this car would be 40 times t plus 2, right? Because you times the two together. Now the second car, what's the rate of the second car? 60 miles per hour? To some time, we don't know, some time t. So the distance for this car is 60 t, right? Now, what are we looking for here? Are we trying to do some kind of mixture where we put them together and make them equal to a result? Are we trying to figure out whether when they're side by side when one's passing the other, so when they've gone the same amount of distance, or what are we trying to do here? So distances are the same whenever this amount is what to this amount. Okay? Do you guys see the difference in this? When you get to this point, you have to look at what the question's asking you. This one wants to know when are the distances equal. So for distance, you set the two distances equal. We'll say 40 times t plus 2 equals 60t. We'll distribute this stuff so we get 40t plus 80 is equal to 60t. Let's move one. I'm going to move the 40t. So remember the sign changes, so the 40 becomes negative 40. Keeps that letter on there. Since I just moved it across, that was it. Now I have 80 is equal to, what's 60 minus 40? Okay, so 20t. Divide by 20 on both sides to get t alone. What's the time equal to? Okay, 4 hours. And that's specifically the time the second car was on the road, right? So 4 hours after the second car left. I guess that's why it would have been maybe smarter to go ahead and use the T for the second car, since that's the one we were looking for. After it left, that time is what we were looking for. So having it be the plain T makes a lot of sense here, right? And when we solved it, we got that it was 4 hours. Good. Let me see if it changes a whole lot for any of these, because really, once you're practicing them, you'll have two different strategies. Sometimes with the distances, you may set them equal depending on the words. Sometimes you may do something a little different. Let's look at example 3 in the text. That'll be the last one of this type we look at, because I know you guys are probably getting exhausted from watching me work the whole night. So let's look at example 3 on page 118. Two cars, one traveling 10 miles an hour faster than the other. So we have a car 1, a car 2. One car is going 10 miles per hour faster. Which one do you want it to be, the first or the second? Okay, so we have 10 miles an hour faster for this one, we'll say. They start at the same time. That's good. And travel in opposite directions in 3 hours. So what's the time for both of these? Both are going equal times here, right? Both are going 3 hours. So in that amount of time, their distance, D, is equal to 300 miles apart. And the question says, find the rate of each car. So find the rate. Let's fill in what we got. Type her name. I'll say car 1, car 2. What's the rate of car 1? Do we know? How fast is it going? No. What do you want to use here? X? Okay. How long is it going for? How many hours? Okay, 3 hours. So what's the distance? Okay, or 3x, same thing, good. Car 2, what's going on with it? How do you know you're going to say plus 10 to that? So see the pattern with these? When you're filling in the tables with the time or the rate, you're going to put the plus 2, plus 10 to show the difference between the two. The time's still 3 hours. The rate, or the distance is going to be 3 times x plus 10 because you multiply across. I'll let you guys catch up to there. So we have to go in opposite directions. The idea is, we have one car going this way. We started here. One car going this way. So what we're being asked is what is that total distance, right? Or what's the rate when the total distance is what? They actually tell us the total distance. 300 miles? How can I relate this column to my 300-mile total distance? I know the distance of car 1, the distance of car 2, they were going opposite directions. So how can I get this total distance of 300? How can I set up the relationship? Well, if I know this amount to the left, let's say it was 2 miles down the road. If the one to the right was 5 miles down the road, what was the total distance between them since they're going opposite? Really? Be careful. If you started here and one went 2 miles to the left and one went 5 miles to the right, how far apart are they? Adam, 7, right? Do you guys see that? Because it says they're going opposite, add the two distances. And when you add it, what does it equal? Yes, total distance is 300. Perfect. So we'll say 3x plus 3 times x plus 10 equals 300. So notice with this kind, you use the table very similarly, but at the very end, you kind of respond differently based on what you're being asked. You guys see that, how it's similar, but it's a tiny bit different at the end? So that sounds like even if you're having trouble, if you get the one kind, you get partial on the second kind, because you almost made it. I'm trying to feel better. It's true. No more word problems, guys. Done. It's out of the agenda. What do we have here? What is that, like 270 or something? Divide by 6, what are we getting? Well, oh, you said 45? Yeah. Okay, good. I was like, oh, that's not good. I thought you said 35, and I was like,